Hello, we're going to talk about Chapter 4, and Section 4.1 is Visualizing Variability with a Scatterplot. So Scatterplot is a primary tool for examining two variable relationships when both variables are numeric. So if we look at a scatterplot, the question is, what is the data telling us? So when we look at a scatterplot, which is kind of like a bunch of dots all spread out, we want to look at the form or shape. So a linear relationship, would the dots are forming a line. It could be going up or it could be going down, but that'd be a linear relationship. And then there are curve relationships, and there's many curve relationships out there. We're going to be focusing mostly on linear relationships, but there's quadratic, exponential, logarithmic, logistic. There are many curve relationships. But again, we'll be focusing mainly on linear relationships. Then we can look at the direction or trend. So positively associated means as the x goes up, the y goes up. So this would be a positively associated relationship. Negatively associated would be as the x increases, the y decreases. That would be a negative relationship. And then the third thing we're going to look at is strength. And strength's a little weird, but for right now, let's just talk about strong and weak, and we'll get into details later. So a strong relationship would be when all the dots are close together. It could be going up or down, but the idea is that the dots are close together, forming a strong relationship. And if the dots are all over the place, that would be a weak relationship. So kind of in review, this would be a linear, positive, strong relationship between the x and the y variables. Okay? So let's talk about creating a scatter plot. So we have some real data here, but before we go into the data, we have to talk about explanatory and response variables. So the question is, which is x, which is y? So explanatory attempts to explain the observed outcome. Explanatory is your x. It explains what comes first. The response is your y, the outcome of a study. So we're going to look at a couple examples and talk about what if it's an explanatory response relationship, or if we're not sure, and we're going to say explore the relationship. So your first example is the amount of time a student spends studying for a statistics exam and the grade in the exam. Well, this can be seen as an explanatory response relationship. So the explanatory variable would be how much time you spend studying, and the response variable would be the grade on the exam. And that could be a positively linear relationship. The more you study, the better the grade. Now again, you could also argue that it's a curve relationship where the more you study, the better you get, but you could overstudy, which may not happen to you, but you can overstudy and lose information. So you want to study a little bit each day. So the weight and height of a person. Now in this case, they're trying to say that your weight determines your height, but I think there's too many exceptions where if a person is 5'9", let's say, can we say how much they weigh, or there's too many exceptions? So in this one, I'd say explore the relationship. We're not sure if there is a relationship there. And then the amount of yearly rainfall and the yield of a crop. Well, that one can be considered explanatory response. So how much rain explains, there's our x, how much yield of crop we get. So again, it could be a more rain, more crops, or maybe that curved relationship again. And then the last one is students' grade in statistics and in Spanish. Now, there is a relationship with how much you study and how well you do in school, as we talked about earlier, but maybe these are two totally different subjects, and we're going to put explore the relationship. But you can argue for any of these, and some people might argue that statistics and Spanish are both foreign languages, right? Just kidding. So, again, we're going to first determine our x and y. We're going to determine which one goes on the horizontal axis, the x, and the vertical axis, the y. And if there's no relationship, then it doesn't matter which one goes where. And we're going to try to use the entire graph. When we do this, we're going to label everything and have a good scale based on the data. So here's our set of data. Manatees are large, gentle sea creatures that live along the Florida coast. Many manatees are killed or injured by powerboats. Here are the data on powerboat registrations in thousands and the number of manatees killed by boats in Florida in the years 1977 to 1990. So we have the years here, powerboat registrations in thousands, and manatees killed. So in 1977, 447,000 powerboats were registered, 13 manatees were killed. In 1990, 719,000 powerboats were registered, and 47 manatees were killed. And we're trying to see if there's a relationship there. But step 1. Before we get started, we don't touch our calculator. Step 1, we need to determine if it's an explanatory response relationship and which one's which. So if we look ahead, we're deciding that the explanatory variable is the number of powerboats registered. This would be our X. And the response variable would be the number of manatees killed. This would be our Y. So we're trying to see if there's a relationship between how many powerboats are registered and how many manatees are killed. That's step 1. Again, we're not going to run to our calculator yet. Step 2, we're going to work on making our scale. Now this one's already done, but I'm going to just talk about the scale first. So we need to fully understand the problem. So we're going to put number of powerboats registered here. We're going to put on the x-axis. We're going to put number of manatees killed on the y-axis. And we're going to decide where to start, where to end. So if we look at the data, the lowest powerboat registrations is 447, and the highest is 719. So not only do we need to know what to start with, we also need to know what to end with and what to count by. So I'm going to start with 400, and I'm going to go to 750. 400 is before 447, and 750 is after 719. And if I'm going to start with 400 and go to 750, I'm going to count by 50s. Now, that's not the only way to do this. You can go from 400 to 800, counting by hundreds. You can go by 440 to 720, counting by 20s. But we don't want this to be a lot of work and a lot of hashes along the way. So we want to take our time and think first what would make sense reasonably. So on our x-axis, I've decided to go from 400 right in the corner to 750, counting by 50s. And we'll do the same thing for the manatees killed. The lowest is 13, the highest is 50, so be careful there. So again, thinking about that, I'm going to start at 0 and go to 60, counting by 10s. But again, you could have gone from 10 to 60, counting by 10s. The idea is that we want to make sure all the data is represented a little bit before and a little bit afterwards. Okay, so all of that is done ahead of time. Now we're going to go to the calculator. So when I go to the calculator, remember we've been using the calculator a lot. So we want to start with a clean calculator. So anytime you go back to the calculator, what I tell people is you want to go to second y equals, make sure all your plots are off. You can also just go to y equals, make sure plot 1, plot 2, plot 3 are unhighlighted. So for example, if you happen to have 1 and 2 highlighted, you would go up to them, hit enter, enter, and make them unhighlighted. So we want to start with a nice clean calculator. We're going to put this data in our calculator. I'm going to put powerboat registrations in list 1, and I'm going to put manatees killed in list 2. So we go to the calculator, stat, edit, in list 1, I put all the powerboat registrations, and in list 2, I put all the manatees killed. Double, triple check your data. If one set of data is wrong, then the whole thing will come out wrong. So be careful, careful, careful. Okay? So for the calculator, step 1, put the data in the calculator. Step 2, let's talk about our window. So when I go to window, I'm going to type in what my window is. Now you may be remembering zoom 9. Now if I do zoom 9, will it work? Zoom 9. Okay, what happens is zoom 9 kind of does whatever it wants. So first of all, if I go to second y equals, go to plot 1, turn it on, choose Scatterplot, x is list 1, y is list 2. At this point is where I would hit zoom 9 for the window. Now, does it work? Yes, but I'm not going to recommend using zoom 9 at this point. Because if I go to window, notice it went from 419.8 to 746.2, counting by 44.25s. That's not what we would do. Same thing for the Y, 6.71 to 56.29, counting by 10,000s. It works, but it doesn't do a great job. So what I would recommend is hitting window and you creating the window based on what we have here. So X minimum, 400, X maximum, 750, counting by 50s. Y minimum, 0, Y maximum, 60, counting by 10s. So if I go to my calculator, 400 to 750, counting by 50s, and again we decided this ahead of time. 0, to 60, counting by tens. Then hit graph, just graph, and there's your dots. So we take those dots, we draw them here, and then we can answer some questions. So, what is the trend? The trend is positive, going upward, which means as the powerboat registrations increase, the number of manatees killed increases. We have a linear relationship. The shape is linear, forming a line. And if I had to pick between strong or weak, the dots look like they're fairly close together, so we're going to go with strong, but we'll get a little more detailed there. So make sure you practice, practice, practice. And below, we have the calculator steps here for you to practice. And there's another example that we're going to talk about below, but we're going to stop there.